Hi, welcome to the class. In this class, we will install Python and Jupyter notebooks from Anaconda distribution. Google for Anaconda downloads and click on anaconda.com downloads. This is the downloads page for Conda. Conda is the most popular distribution center for Python related packages. When you install Conda, it will come with a number of Python packages including Python interpreter and Jupyter notebooks. This Conda comes in three flavors: Windows, Mac and Linux. In this video, I'll be installing the Mac version. Next, Anaconda comes with two versions, Python 3.6 and 2.7. I'll be using Python 3.6 for this course. Next, it comes with two ways of installing, graphical installer and command line installer. Let us choose the graphical installer. It's a large file, about 600 megabytes. It will take about a minute or so to download depending on your internet speed. I'll pause the video for a minute. Download is complete. Let us go to the downloads folder. Double click on the tar file. It will start the installation. Click on continue. Next, it gives the list of all packages this Anaconda installation comes with. Just browse through them if you want to, and then click continue. And this is a licensing agreement. Read it if you want to. Then click continue. Here we can customize your installation, change the installation location, etc. I'll go with the standard installation. I'll just click install. This will take about 5-6 minutes to complete the installation. I'll pause the video. Installation for Anaconda is complete. Now let us open a terminal window. Let us type conda help. It will give you all the list of commands we can execute on with the Conda. One is a list. The Conda list will give you the list of all packages that is available in this Conda environment. And then Conda create, we can create virtual environments using Conda. This is very useful. And next one is install. If you want to install any new packages, we can use Conda install. And the Conda update and Conda upgrade for upgrading the existing packages, and remove is for the removing the current packages, and also uninstall is also there. It does the same thing as remove. And let us see what are the packages installed with this Conda. Just a Conda list that will give you all the packages that are installed in this installation. So these are all the packages. Let us go through some of the packages. A beautiful soap. This is used in web scraping projects. And there is a bouquet. Bouquet is one of the popular packages for visualization package. And then there's a Conda. Conda is like a package manager. That's what we are using right now. And then there is a Jupyter. Where is Jupyter? Jupyter is this we will be using a lot in this course. It is one of the best learning tool for learning Python and other languages. And there is NumPy. This is a NumPy. This is a NumPy module. This is for creating the multi-dimensional arrays. And then there is a pandas. Pandas is for creating the series and data frame objects. We'll be learning a lot with these packages in this course. And then there's OpenPyXL. OpenPyXL is an excellent package for working with Excel worksheets. And so these are all some of the important packages that comes with this installation. Yeah, next let us bring up the Python shell. I'll just clear the screen and just say Python on the terminal window. It will bring up the Python shell. See the version, the Python we installed is 3.6.3, and in this shell we can write Python code and execute it. Let us write our first Python program. Let us print hello world. So that is how to write Python code. Just say print hello world. That will print out the string. This also works like a calculator. Let us say 10 plus 20 will give 30. And also let us create some Python objects. I'll say n1 equal to 10, n2 equal to 20, and n3 equal to, let us say, n1 plus n2. Let us print n3, that will be 30. In Python there is no need to specify the data type. See, here we are creating a variable, an object, a numerical object n1, and we are assigning the value 10, and we didn't specify the data type. Python interpreter automatically infers the data type basing on the value. Suppose if we say we can check the data type by using a function called type n1, that will give you the type of the data type of that object, that n1 object. That is it says it's a class of a int class. Similarly, if we want to create a float object, we can say f1 equal to 10.5. Basing on this value we are assigning, it will decide the data type. Now if we say the type of f1, it will be a float. Similarly, we can create a string object. Let us create let us say s equal to let us say hello, and if you want to see the type, it will be a string object. I just want to give a feel for the Python shell that comes with the installation. For the most of the lessons in this course, we'll be using Jupyter notebooks. Okay, we'll stop here, and in the next class I'll show you how to bring up Jupyter server and some basics of using Jupyter notebooks. Okay, let us quit this one. We can say quit. Let us stop here, and we'll meet in the next class. Okay, thanks. Hi, welcome to the class. In this class, we'll be installing Python and Jupyter notebooks from Anaconda distribution. Google for Anaconda download, and you'll be coming to this page, and click on anaconda.com download, and this is the downloads page for Anaconda distribution. Anaconda is the most popular distribution center for Python related packages, and Conda is the package manager for Anaconda distribution. When we install Conda, it comes with a number of Python packages including Python interpreter and also Jupyter notebooks, and this Conda comes in 3 flavors: Windows, Mac OS and Linux. In this video I will be installing Conda for Windows, and again it comes in 2 versions, Python 3.6 and 2.7. I'll be using Python 3.6 for this course, and again this comes in two versions, 64-bit and 32-bit. Depending on your system, use one of these, and I will be installing on a 64-bit machine. And this is about 500 megabytes file, and it will take a minute or so for downloading this file. And I'll pause the video. Yeah, download is complete. Click on open. And this is the screen for installing the Anaconda. Click on next, and this is a licensing agreement. Just read it if you want to, then agree for that, and install for just for me. This is fine. And this is the folder where it will be installing users, your home directory, and Anaconda 3. If you want to change it, you can use this button, and I'll just install in the default directory. And this is important. Add Anaconda to my path. Click here, and register. If you want to register, click here, and then go with the installation. And this will show you all the files it is working with. This is a big installation. It will take about 12 to 15 minutes, and I'll pause the video. Installation is complete. We finished installing the Conda. Next, open a command prompt, and if you want, you can go to the start button and click on command prompt. And if you want to change the font or colors, you can do that by using these properties. You can change the fonts or the colors and all that. Okay. On the command prompt, type conda help. That will give you all the commands of Conda. One of them is a list. By using the Conda list, you can see all the packages that are installed in the installation. And then Conda install will help you to install new packages. You can say Conda install and the package name. And also similarly, update and upgrade, they both are same for upgrading the existing packages. And if you want to remove any packages, you can use remove or uninstall. Both does the same thing. Remove or install. Conda remove, Conda uninstall. And these are some of the important options with Conda. And one more thing is the Conda create. Conda create is really useful if you want to create a virtual environment, a Conda virtual environment. You can use Conda create. Let us see Conda list. Conda list will give you all the packages that are installed with the Conda. And let us see some of the packages. We have the Python, where is Python? See here, Python 3.6.3 is installed, and the other one is the Beautiful Soup. Beautiful Soup is a package used in web scraping projects, and the Bouquet is another data visualization package. And we have Conda. Conda is a package manager. That's what we are using right now. And this Jupyter. Jupyter is an excellent learning tool. most of the scores I'll be using this Jupyter package. And then we have NumPy. NumPy is for creating the multi-dimensional arrays and all that, and pandas is for creating the series and data frame objects. We have a separate sections on NumPy and pandas, and also this good open PyExcel is an excellent package for working with Excel worksheets, and there's a lot of nice packages in this installation. And let us look into the Python shell. If we type Python, it will bring up the Python shell, and this is the version we are using. This is the one we downloaded, Python 3.6.3. This is the Python shell. Here in this one you can type in Python code and execute it. For example, you can say print, let us write the first code, Python hello world. That will print the hello world. And also this works as a calculator. You can say 10 plus 20, that will give you 30. And also you can, let's create some Python objects. I'll say n1 equal to 10, n2 equal to 20, and let us say n3 equal to n1 plus n2, and let us print n3. In this shell there is no need to use print. We can just directly say n3. It will give you the value of n3. These are all objects. The Python variables are objects in Python. In Python there is no need to specify the data type. Here we are just saying we are creating a object n1 with the value 10. Depending on this value, the Python interpreter will infer the data type for this object. And also there's a method, also there's a function to find the data type of this objects. We can set type n1 will give you the class of that object. This is an int class. This is an integer class. Similarly, you can create a floating class object by, let us say, f1 equal to like a 10.5. Basing on this value, the Python interpreter will decide the type of this object. Say type f1 is a float object. Similarly, we can create a string object. We can say s1 equal to hello. That is we can see the type of s1 will be a string object. I just want to give a feel for this Python shell, but I will not be using this Python shell for this course. Most of the time we'll be using Jupyter notebooks. And to quit this one, we just say quit, and you will be back in the command prompt. Okay, we'll stop here, and in the next class we'll see how to use Jupyter notebooks. Okay, thank you. Hi, welcome back to the class. In this class, I will start with regular expressions. A regular expression is a sequence of characters that define a search pattern. Let me repeat. A regular expression is a sequence of characters that define a search pattern. For example, the word cat, cat, is a regular expression, the sequence of characters. Similarly, here there's a ca plus t. The plus is a repetition meta character in regular expressions. So ca plus t is another regular expression. This is a little more complicated regular expression. I'll explain in this section. I will be explaining how to write quite complex regular expressions. Regular expressions is a little complicated topic, maybe one of the a little tough topic in this course, but I will try to make it as simple as possible. Okay. Then these regular expressions are typically used in applications that involve a lot of text processing, and also they are also integral part of command line utilities like sed, grep, and awk. Uh, if you are familiar with these utilities, then you must be knowing about using regular expressions. Programming languages like Perl, Ruby, and Awk, they are heavy into regular expressions, and the regular expressions is part of the core language itself in these languages. Whereas in languages like in C, C++, and Python, the support for a regular expression is through external libraries. Python standard library provides a module called RE for regular expressions. Okay. In Python, syntax of regular expressions is very similar to Perl. So suppose if you already know Perl and if you have done some work in regular expressions, then this will be a cakewalk for you. Regular expressions are also referred as RegEx or RegExp. Learning regular expressions involves two steps. First is we must learn how to use RE module methods. It's a regular expression, so there's the module RE module. We have to learn how to use the methods. The second one is how to write search patterns using meta characters and all that. Let's look into the RE module. What are the methods, important methods in RE module? Here are some of the important RE module methods. One is the search. It looks for the match for the pattern anywhere in the string. This is what you have to remember. The search method will look for the pattern anywhere in the string. If the match is found, it will return a match object. If the match is not found, then it will return a none. Next, the second one is the match method. This is very similar to search, but this will look only in the beginning of the string. It will look for the pattern, whatever the pattern we are passing. It will look for this pattern in this string only at the beginning of the string. Whereas in search will look anywhere in the string for this pattern. And they are almost similar. Only thing, the difference is the match will look only at the beginning of the string. If the match is found, this also will return a match object, and if the match is not found, then it will return a none. And this match object comes with some methods like a groups, span, start, and end. We'll see with the code examples all these methods, how to use the match object. Once we get a match object from a search or a match, we'll see how to use these methods. Next one is findall. Findall is very important method and is widely used in regular expressions in Python. Findall, we'll be passing the same parameters, the pattern, string, and some flags. We'll be looking into these flags at the end of this course. And this returns a list of all non-overlapping matches in the string. Means whereas this match and search will return only the first match found, whereas the findall will return all the matches in the string, all the matches that match with the pattern. It will return a list object with all the matches. Next, finditer. Finditer is very similar to findall, but it will not return a list object. It will return a iterable object, and we can use this iterable object. We can iterate on that iterable object by using a for loop to get all the matches. This method is useful when you are expecting like thousands of matches. Suppose if you are passing through a large amount of text, and if you are expecting thousands and thousands of matches, then this is the best method. This is the finditer, because it won't it will this method will conserve the memory. It won't give all the matches, but it will give an object, iterable object. You can use that object, and you can iterate on that object by using a for loop. Okay, that is about find all and find iter. Let me repeat. Find all will return a list object with all the matches in the string, all the matches that match with the pattern. Okay, and whereas find iter will return a iterable object by using we can use that iterable object with a for loop to get all the matches in the string. Then there is a sub method. Sub is more like a search and replacement. So search sub came from a substitution, and here we'll be passing the pattern and also the replacement string and the string where we want to search for the pattern. And also we can say, we can pass a count how many replacements we want to make, and also the flags. Then there is a compile method. Compile, suppose if you are using the pattern number of times in your code, it is better to compile once and use that pattern and again. So there's a compile method. We can compile and it will return a pattern object. We can use that pattern object in all our subsequent searches. Then there is a split method. A split method is this is a more powerful method than the string split method. One thing is in this we can pass multiple delimiters, whereas in a string split method we can pass only a single single delimiter, like a space character or a comma or a period, whereas in RE regular expressions split we can pass multiple delimiters. Let us recap what we learned in this section. A regular expression is a sequence of characters that define a search pattern. So for example, a simple word like a cat, CAT, is a regular expression, or with a CA plus T here is the plus is a meta character, is a repetition character. This is also another regular expression. Regular expressions are mostly used in text processing applications. And also we learned that Perl, Ruby, and Awk, these are heavy into regular expressions. And the Python standard library provides a module called RE for regular expressions. We'll be using this module with all our examples. And learning regular expressions involves two steps. One is learning the RE module methods. The second one is how to write search patterns by using the meta characters and all that. And next we saw the various methods available in RE module. One is search, and the search method will look for the pattern anywhere in the string. And also next one we saw is a match. Match is very similar to search, but it will only look for the pattern only at the beginning of the string. In these two methods, if a match is found, it will return a match object, and if not, it will return a none. Then there are some methods on this match object, like a group, groups, span, start, and end. These are all the methods we can use on this match object. Once a match object is, once we get a match object, we can use these methods on that match object. Then we saw the two methods, find all and find iter. Find all will return a list object with all the matches of all the matches in the string with this pattern. So it will give a list object with all the matches. A find iter is very similar to find all, but it will return a iterable object, whereas find all will return a list object. Find iter will return a iterable object. This method is useful when we are expecting thousands and thousands of matches when we are doing a large scale processing of text. Next, we saw a sub method. Sub method is more like a search and replacement method. Here we can also pass the number of replacements we want to make by we can pass a count. Next, there's a compile method. We can use this compile method to compile a regular expression. Suppose if you are using the same pattern multiple times in your scripts, we can just compile in the beginning and use that pattern object in further searches. Next, there's a split method. This regular expression split method is more powerful than the regular string split method, because one important thing is we can pass multiple delimiters. We'll see all this with a lot of examples in our next class, and we'll stop here and we'll meet in the next class. Okay, thanks. Hi, welcome back. In this class, we'll look into some code examples on RE module methods. Let us first import RE. Let's say import RE, and let us create a text string. I'll say this is a beautiful day. There's a simple text string for testing our methods, and I'll execute this one. Next, let us call the search on this. I'll say re.search, and for that we have to first pass the pattern, what the pattern we want to look into this string. I'll say or is, and I look for the string is in text one. If I execute this one, I get a match object. The search has found a match at location 2, starting at location 2 and ending at 4. The match found is right. Let us create an object with this. I'll say m equal to, I'll just copy this. So we got a match object m. We can call some methods on this. I can say m dot group will give the actual match, and I can say m dot start and m dot end. It will give you the start and end of the match. It started at location 2 and ended at 4. And also there's another method called m.span. m.span will give the same information on the start and the end. So those are the methods available on the match object. Let us then look at this, the second method, match method. Match method is very similar to the search method, but only thing is it will look for the pattern in the beginning of the string. I'll say m equal to re dot match, and let us look for the same pattern. Let us look for is, and then let us pass the same string text one, and we got a match object. But let us see if it is a real match is found, or if I print on m, it will say none. No match is found, because the text string, there's nothing, because it is looking for at the beginning of the string, and it could not find is, so that's why we got a none here. Suppose if we look for th or this, let us look for th. Then if we print m, you got a match object. On this again we can do m dot group, and also we can do m dot group. We can do m dot start, also m dot end. Also we can do m dot span. All these fun methods we can run on this. So this is the match found. and start at location 0 and end is at 2. And the span, this is the span from the span method. So that is about how to use the string, the search and match. The search will look for the match from anywhere in the string, whereas the match method will only look at the beginning of the string. And also both these methods will return only one match. Only once it finds a match, it stops there and it just gives the one match, the first match found. Then let us see the third method, findall. Findall will give a list object with all the methods found. Let us use the same text string, text one. I'll say re dot find all, and let us pass the same pattern. I'll say r. I'll say is, and text one. Note here I'm creating a raw strings here. This when I start with r, this string becomes a raw string. This we learned in string object basics. So if we put a small r before a string, it becomes a raw string. The difference between a raw string and a regular string is simply that raw strings do not interpret the backslash characters as an escape character. So that is very important, because sometimes we'll be using a backslash characters inside this string, inside this regular expression. So always put a r, small r in front of the string to make it as a raw string. Let us execute this one. See, this is a list. We got a list object with all the matches found. Let us change the test string. Let me copy this string. I'll say, let us run this one. Find all method. I'll run it on text 2, and here I look for the string BA. If I execute this, these are the matches I found. It starts with BA, this one, and again the next BA is here, and the next BA here, and the next BA here, and the next BA here. It gives all the non-overlapping matches. It gives as a list object with all the non-overlapping matches. Next, let us try the finditer method. I'll say re dot find iter. Let us use the same pattern, or let us look for BA, and I'll pass a text to finditer, and we are passing the pattern, and this is the test string. And let us save it to an object. Let us say mat. If I execute this, mat will be a iterable object. If you see the type on mat, it is a iterable object. We can run a for loop on this. I can say for m in mat. Mat is a iterable object. Let us say print m dot group, and let us say m dot start. This m is a match object. So when you iterate on this mat iterable object mat, it will give in each iteration it will give a match object. And m dot end. If I execute this one, this is my output. First m dot group will give the actual match, the BA, and this is the starting of the match, and this is the ending. Again, the next match starts at 10 and 12 and so on. Okay, that's how to use this is more useful. Suppose if you are expecting thousands of matches, this is the best way of doing. because it will conserve the memory. It will just give one object, whereas here in the find all method is giving all the items, all the matches as items in a list object. So suppose if you have 10,000 matches, then it will give a list object with the 10,000 items. That is not a good way of programming. If you are expecting a lot of matches like in thousands, always better to use the finditer method instead of find all. Okay, next let us see the sub method. The sub, let us see what is the text2 we have. Text2 is okay. Let us use this one. Sub is for substitution. So I'll say r dot sub, right? Let us use the same pattern. Let us look for BA and replace with let us say XY. Okay, BA with XY, and I will pass a text2. If I execute this one, see all the BAs are replaced with XY. Here there was a BA and it was replaced, and all the there are 5 matches earlier. All these are replaced with XY. Okay, and let us pass a counter to this. Let me copy this. We can pass a count. How many replacements we want to make. Let us make 2. If I execute this one, we get only 2 places it is replaced. Here this is one, the other one. The rest of the BAs are intact. So only this is we can pass the number of replacements we want to pass to this one. Next, let us see a compile method. How to use a compile method. I'll say re dot compile. Compile is another method in RE module. I'll pass the same pattern or BA, and this will return a pattern object. I'll say pat equal to. So if I execute this one, I get a pattern object. I can use this in methods like search, or I can use it in findall or finditer and all that. Let us use it in findall. Findall, I use the compiled version, compiled pattern pat, and let us pass the same string text2. If I execute this one, I get the same as it was before. Here we got when we did a findall, here we got the 5 matches. So same thing we got here by using a compiled pattern. So that is how to compile. This is very useful if suppose in your script you have doing multiple searches with the same pattern. It is always best thing is to improve the efficiency of the script. It is good to compile in the beginning and use it later in all the searches. Next, let us see how to use a split method in RE module. Let me copy a test case. First, let us do a string split. Text3 is a string object. On that, I can run a split method. I say text3 dot split. This is a regular string split. If I execute this one, I get a list object with all the various splits. So it is this string split is doing a split on a default character, that is a space character. So it is splitting on the spaces. Wherever there is a split, it is splitting. Okay. Now let us try with a RE split method. I'll say RE dot split, and I'll pass a pattern. I'll say split on space, also split on semicolon, colon, and a comma, I want to split on all these characters. So this is the speciality of RE split. We can pass multiple delimiters, whereas in a string split we can only pass a single delimiter, and also we can specify this uh, split on multiple spaces. And write text 3. If I execute this one, I get a more cleaner. All these punctuation marks are removed. The semicolon is removed, and colons are removed, and all that, because it is splitting on these characters, on multiple characters. This you may not be able to appreciate right now, but in the next class, when we start writing regular expressions by using various meta characters, then you will understand what exactly is the meaning of this one. Let us recap what we learned in this class. First, we imported a RE module, and then we saw how to use a search method on RE module. And once we use the search method returned a match object. On match object, we ran a couple of methods like group, start, end, and span. And then we saw how to use a match method. A match method, the difference between match and search is search will look for the pattern anywhere in the string, whereas the match will look only in the beginning of the string. Next, we saw how to use findall. Findall will return a list object with all the matches found. And there's another method, finditer. It will return a iterable object. Instead of a list object, it will return a iterable object. We can iterate on that object by using a for loop. Then we saw how to use a sub method. Sub is for search and replace. And here in sub, we can also pass the number of replacements we want to do by using this count. And then we saw how to compile a regular expression, and finally we saw how to use a split method in RE module. We'll stop here, and in the next class we'll start writing regular expressions. Okay, thanks. Hi, welcome back. In this class we'll be learning how to write regular expressions, and we'll be covering these 8 topics in this section. One is repetitions, how to write repetition characters, and next how to make the repetitions non-greedy, and how to use character sets and character ranges, and how to use escape codes, and how to do anchoring, and also how to use the flags in regular expressions methods. Also, we'll see how to use groups in regular expressions, and also what are named groups. Okay, let us start with repetitions. Repetitions, these characters are repetition characters: a star, a plus, a question mark, and a number within a curly bracket, and also 2 numbers. These are minimum and maximum, these 2 numbers in a curly bracket. All these are all repetition characters used in writing regular expressions. Dot stands for, in regular expressions, it stands for a non-new line character. Any non-new line character we can represent with a dot. Let us see the other characters, repetition characters. First is a star. Star stands for 0 or more. That is the meaning of star. 0 or more times of the preceding character. For example, here this is a regular expression, AB star. The star says 0 or more times of the preceding character, that is B here. All right. So this AB star represents A followed by 0 or more times of B. So this is these things you have to get into your mind. These are very important in writing regular expressions, and also if you are good in regular expressions, that will really help in facing interviews. Next, that is about star. Star is 0 or more times of the preceding character. Next, plus. Plus is slightly different. Plus is 1 or more of B's. 1 or more of the preceding character. Here the preceding character is B. So this construct, this regular expression says A followed with 1 or more of B's. 1 or more of B's. That's what is this construct will say. Next, the third one is a question mark. Question mark says a 0 or 1. Only it could appear, the preceding character could appear 0 times or 1 time. That is max. So these are the three most important characters, repetition characters: a star, a plus, and a question mark. All right. And then next one is a number in a curly bracket. Means this is it says n times of the previous preceding character. That is here it says A followed with n times of B. That's what my regular this is a regular expression says, n time A followed with n times of B. It's a number, is a fixed. Suppose if you put a 3 here, that A must followed with 3 B's. All right. And next one is and two numbers, m and n. Here we are specifying minimum and maximum. So minimum is minimum times the preceding character must appear, or the maximum times it can appear. I mean, it cannot go beyond this number. Suppose if we say 2 and 3, it must 2. I mean, B must appear 2 times. A must be followed with 2 times of B, and maximum is it can appear is only 3 times. A followed with 3 times. That is the minimum and maximum. The next one is m, the one number followed. There's no maximum number here. Means maximum it could appear unlimited times. But minimum times it must appear is m times, but maximum it could appear any number of times. All right, that's what it means. A followed with B, minimum of m times, but there's no maximum. It could appear any number of times, unlimited. All right, then there's a dot. Dot stands for, as I said before, is any single non-new line character. That's what a dot stands for. Any non-new line character. So here this regular expression says AB followed with any non-new line character. That's what this construct says. So this is all about repetition characters. The repetition characters, let me repeat quickly. The repetition characters are star, plus, question mark, and a number in a curly brackets, and 2 numbers in a curly brackets. These are all repetition characters. And the star says 0 or more times of the preceding character, and plus stands for 1 or more times of the preceding character, and a question mark says 0 or 1 time of the preceding character. A number in a curly bracket indicates that so many times the preceding character must appear to have a match. All right, m and n is here. It is a minimum and maximum, and here without a maximum number means it's unlimited. And again, the dot stands for any single non-new line character. That's what dot stands for. Let us now see some code examples, and that will make it more clear for you. I'll copy a text. Let us use this text for our examples. Then let us run this re.findall, and let us write the regular expression. I'll say AB and star. That is my regular expression. and I'll pass the text, right? This is my regular expression. This is what A followed with star is what 0 or more times of B. A must be followed with 0 or more times of B. If I execute this one, this is what I get. I started here. It was looking for A followed with B. Here this is fine. It took it because A is followed with 0 or more times. Similarly, it got ABB. That is fine too because there are two B's. That is fine. A followed with two B's, and here A with followed with the 0 times of B. That is also fine with star because star says either 0 or more times of B. So that's why it took all A's too, and this whole thing. All right. Okay, let us try with the plus sign. What is the plus sign says? It is either one or more times of the preceding character. If I execute this one, right? First, this is good. Is followed with the 1B. 1B is fine. Here too, there are two B's. That is fine. One or more, right? And here there's no B. Regular expression engine is skipping all this because there are no B's. There must be at least one B. That's what plus says. The preceding character must, the preceding character must be there at least one time. So these three are skipped, and then it is taking this one and this one. All right. Next, let us see the question mark repetitor. Let us see the text now. Text is that one, and let me copy this. I'll replace plus with question mark. If I execute this one, this is what output I get. Let us see what the question mark says 0 or 1 time of the preceding character, right? Here AB is fine because it's only one. We got AB. From ABB, it just takes AB because it cannot take two B's. And then all these three A's are taken because A followed with the 0 times of B. So this is what question mark says, either 0 or 1. So that's why it took the 3. And from here, it just takes AB and AB. All right. Let us see the one with the curly brackets. I'll say, let me change this one to a curly bracket. I'll say 2. So this is our regular expression now. Okay. If I execute this one, this is what we get. Here we are saying that A must follow with at least A must follow with the two B's, not at least. A must follow only with two B's. That's what it says. And this is our text, AB. So AB, we cannot take AB because there must be two B's. So it took next one is ABB. That is fine. We took ABB, and this we cannot take this. And the next one is from here it takes ABB. That's it. It has to be only two B's. The skips the rest too. And from the next one also it takes ABB. That's why we got ABB. It has to be ABB because we are specifying it has to be the preceding character must be repeated 2 times only. Let us see the other one, minimum and maximum. I say let us first let us print the text here. Text. All right. Copy. I say 3 and 4. All right. If I execute this one, I get A followed with see it says A followed with 3 B's at least, or maximum of 5 B's, right? All this we cannot, all these we cannot take, right? How about this one? It has 4 B's. Okay, we can take this. even though there are minimum is 3 Bs, right? But it has 4 Bs. That's fine. We can take this. And here it has how many 7 Bs are here, but we cannot take 7 Bs. It can take only up to here. It matches only up to there. That's why it got 5 Bs. A followed with 5 Bs. Minimum 3, maximum 5. That's it. Here it was 4. That's why it took 4. So these repeaters are also called greedy repeaters. Greedy means they try to take as much as possible. Here, for example, there are 4 Bs, right? And it took all the 4 Bs because it can take anywhere from 3 to 5. But because there are 4, it took. It is not taking the minimum; it's taking the maximum possible. Here there are 4. That's why it took 4. Similarly, here it is not taking. It says minimum 3, but maximum is 5. So it's taking the maximum, taking the whole thing as much as possible. I mean, according to this expression, the maximum it can take is 5. That's why it is taking the 5. It's not taking A followed with the 3 Bs. It is taking A followed with the 5 Bs, the maximum possible. That's why these repeaters, all these the star, plus, question mark, all these are called greedy repeaters. Greedy, but there is a way to make it non-greedy. For example, let us see one more example. Here, star say, here says 0 or more, right? It can take here. It can make it as a 0, but it's trying to make it pause as much as possible. That's why it is taking AB instead of just A. Similarly, here, for example, it has 4 Bs, right? It can take either 0. It can just check. It can just take just A, but it's trying to get as much as possible. That's why it is taking all the 4 Bs here. That's why it's the star, the plus sign, the question mark. All these are called greedy repeaters. They try to match as much as possible. But there is a way to make them non-greedy by just adding a question mark. By adding just a question mark at the end of the repeaters, we can make them as non-greedy. Let us see some code examples on that. Okay. Let us take the same text. All right, and let us take one of the examples, like let us take this one, right? If I execute this one, this is the original, is greedy one, right? This is what we got before. We can make this as non-greedy. We can put a question mark here. If we put a question mark, it becomes a non-greedy repeater. We are changing we are adding something to this repeater star. We are making it as a non-greedy by adding a question mark. If we execute this one, it will try to match with the minimum. I mean, what is the meaning of a star? Star says either 0 or more of the preceding character, right? So it will try to make it as 0. Let us see what we get. So we got all A's because it says, I mean, wherever is it's just making the B as 0 times. Here just we got A. Here we just got A, and all the here just taking A and skipping B. It is making as a non-greedy repeater. All right, let's try with this with a plus. First, let us say what we get with the plus. Suppose if we run with just a plus, this is the output we get. And then let us try with the plus star. So what is the plus says? Plus says either 1 or more of the preceding character. If this one will try to make 1 A followed with just 1 B. Let us see what we get. This is what we got. AB Let us see the text. This is the text, right? AB, just to get AB. Here from ABB, because it's trying to make it minimum, it made as AB. Whereas the greedy one, without a question mark, it just took the whole thing. It just took ABB here. Similarly, here it cannot take AAA because it has to be at least 1. The plus indicates that it has to be 1 minimum. So it just is skipping all this, and from the next two strings AB and from this one it's just taking AB and AB because it's a non-greedy one. All right, that is how to write a non-greedy. Let us try with the question mark also. This is the text, and suppose I will say the question mark. This is the regular greedy one. Let us see what happens. It will the question mark says either 0 or 1 of the preceding character, preceding B. So it is trying to, because this is a greedy one, it's trying to get a maximum possible from AB here, and here these are also qualified because of the 0 times of B is fine. So, but wherever possible, it will get the maximum. That is, the maximum is to have 1 of B. Suppose if we make this one as a non-greedy one, see what we get. If I make it add another question mark here, it will make it this question mark as 0 times. Instead of 0 or 1, it will make 0 times. That's why we got all 0, all A's. Let us recap what we learned in this class. We learned about repeaters and also the non-greedy repeaters. The repeaters are star plus question mark and a number in a curly bracket, and 2 numbers, minimum and maximum, in a curly bracket. These are all repeaters in regular expressions. And also dot indicates a non-new line character. Any non-new line character is indicated by a dot. And the star indicates a 0 or more times of the preceding character. And plus indicates 1 or more times of the preceding characters. And the question mark 0 or 1 time of the preceding character. And within the curly brackets, if you put in a number, it indicates so many times of the preceding character. Similarly, we can specify minimum and maximum of the preceding character, and also we can say we can just give a number and comma, and without any number it indicates unlimited maximum, and minimum is this is the minimum. And the dot, just to remember, the dot indicates a single non-new line character. And the greediness, by default, all these are greedy characters, but we can make them a non-greedy by adding an extra question mark at the end. That we saw with the examples. Okay, we'll stop here, and in the next class we'll see the character sets and character ranges, escape codes, and all that. Okay, thanks. Hi, welcome back. In this class, we'll see how to write regular expressions by using the character sets and character ranges. Okay. A character set is a group of characters enclosed in square brackets, any one of which can match at that point in the pattern. For example, here, this is a regular expression, AXY. XY is enclosed in square brackets. Then the pattern would match either AX or AY. Any one of these characters, either X or Y. Also, we can exclude also. Here we are including in the pattern, we can also exclude. We can exclude these characters. Here we are saying when it starts with a caret sign, it means it would exclude ax and ay, and this caret sign is the exclude symbol in character ranges. Also, as the character set grows, typing every character would be tedious. That is, then we can use ranges. Here we can say, instead of typing all the letters from A to K, we can just say A dash K within these brackets. So it will match with any of these characters from between A and K. It will match with any of these characters. Similarly, we can also exclude. We can exclude all the letters from P to Z. So that is how to use character sets. First thing is these are enclosed in square brackets, and you can specify all the characters. It will match with one of these characters. And also you can exclude. You can say not to include in the match all these characters. You can use with a caret sign, start with the caret sign and specify all the characters. And also, instead of specifying all the characters, also you can put it in a range, like A dash K means match with any character between A and K. And also similarly, you can put a range with a exclusion character, caret sign. This will exclude all the letters from P to Z, matching with these letters. Okay, let us see some code examples that will be more clear for you. Let me copy a text string. Let us use this for our text as a text string. I'll say re.findall, and then we'll write the pattern here. And I'll simply say R is for raw strings. I'll say square brackets xy, right? And I'll pass the text. So this is a simple regular expression. Here I'm just saying a match with either x or y. Match with x and y. If I run this one, I get all the matches. It matched with x here, and then it matched with y. We can match whether it with x or y. So that's why we got all the x and y's, but it skipped g's. There's no g's here. Suppose if I say match with A or B, I won't get anything. I will get an empty list object. Here we are saying a match with x or y. Either of, you can match with x or y. That's why it is matching with here it is matched with x, here it is matched with y and all that. And it's skipping z because we didn't specify this characters z character here. Suppose if I put a z here, it also matches with the z. We get g's also here. So that is how to use a character set. Let us try with a repetition character. Let us add a repetition character. I'll copy this one, and I'll say match with everything starting with the x followed with x or y. All right, let us see what we get. This is what we get. So we are trying to match a character string starting with the x followed with x or y. Here it is matching with xy, right? And after that it is matching with the x followed with the x. And finally there is one more x here, but there is nothing here. So it cannot match with this one. So the output is xy and xx. And let us add some more thing. Let us copy this one, right? If I put a plus here, right? Plus is for what? The repetition character for one or more of the preceding characters. Preceding means this one, right? It could match with one or more of these characters, right? If I execute this one, this is what I get, right? it started with x, right? It has to start with x, followed with any number of these characters. I mean, one or more of these characters. So that's why we got this string. We got this string up to here. Once it saw z, it cannot match with that, so it stopped there. That's what we got here. All right, that's how. Let us. This is a greedy one, right? Let us try with a non-greedy one. How to get a how to make it as a non-greedy? Just put a question mark. All right. Let us see what we get. If we execute this one, we got xy and xx. See, this plus sign says match with one or more, whereas this character, this question mark makes it non-greedy. It says just it will make it match with only one character. That's why we got x with x, xy, and that is from the string xy. We got xy, and I mean it just stopped there. Then again here xx. So it made this is making this. I mean this is making this plus sign as a non-greedy. Let us take another string, another test string. I will say that is our new text string, and let us try with the exclusions. re.findall, right? And let us write the pattern as x followed with any non x and y characters, followed with any characters other than x and y. And if I put a plus here, means any number. If I execute this one, let me put a text here. If I execute this one, this is what I get. What is our text now? Let us see text. This is our text. This is the new text, right? It matched with it has to match with one or more of this, one or more of any characters other than xy. So it started with here xx. It cannot match with x or y, so it skipped all this. And finally here it cannot. Here again there's x. It cannot match with y. Again here x cannot match with y. Then here x. The following, the next character is the space, so it can match with that. So we got a x space. Similarly, it can match with xa, that is fine, xb, that is fine, and xb and space, because it's a greedy one, it also took a space, xb space. And here it cannot match with x cannot match and y and all that. And finally x matched with z. That's what we got here. Suppose let us say what happens if you make it as non-greedy. I'll copy this one. We get different results. We got x, we got the same thing. Here only thing is here it is skipping the space because it is making this plus as a non-greedy. It is just matching on one character, one non-xy character. All right, let us try one more example. Let me take this text string. This is our new text string. I want to match on this word and this word. Let us see how to write that regular expression. I'll say find all, right? Find all. and that is my, there I will write my pattern followed with comma text, right? And we want to pull out this word and also this word. So see, these two words are starting with a capital letter, and these two are just the rest of them are all small letters. Here only these two words are starting with a capital letter. All right, what we can do is we can use the ranges. We can say any letter starting with A to Z, right? A to capital Z, any letter, one letter, and followed with A to Z, small letters, right? And let us see what we get with this. We are saying anything starting with a capital letter followed with a small letter, A to Z. Suppose if you execute this one, this is not what we want. We just got TH and PU. That's not what we want. So what we have to do is we have to put a repetitor for this. I'll say I can put a star, right? Star, it will repeat. It will repeat whatever the characters from 0 to 0 or more, right? If I execute this one, we'll get exactly what we want. So that is how to write a regular expression by using the ranges and also a repetition character. One more example. Let us say we want to pull out all these words without any punctuation marks, right? This dot, dashes, spaces, and also this bangs. I'll say re dot findall, right? And this is our regular expression. To that we'll pass the text, right? And regular expression, let us have a, we want to exclude all the characters. So let us start with the caret sign. We want to exclude all this. We want to exclude dot, all right? We want to exclude a dash, right? And we want to exclude a bang, and we want to exclude a space, all right? And if you execute this one, there's a small problem. We get an error because this dash is the dash is like is used in ranges, but here we don't want to use as a range character. We want to, so we cancel that effect by using a backslash character. Let us see what we get now. So we are getting everything, but this is not the output we want. We want as words, different words. For that, you can put a plus sign here. So if you execute this one, now you get words. Earlier it was matching on each letter, right? So T is not one of these characters. Okay, it is taking ST. Then H is not one of these characters. That's why it's taking H. But we can make it plus. Plus is a greedy repetitor. So that's why if we execute this one, we get all the words without any punctuation marks, and also without any, because here we have a space character also, so we're skipping all the spaces also. Okay, that's how to write regular expressions by using ranges, character sets, all right. And also we used repetition characters here. We'll stop here, and in the next class we'll see the escape characters and anchoring, all right, and also flags. Okay, hi, welcome back. In this class we'll look into escape codes, anchoring, and flags in writing regular expressions. In writing regular expressions, we can use some special codes to find specific types of patterns in data, such as digits, non-digits, or white space. And here are some of the escape codes. For example, slash D matches with a single digit. Slash D matches with a single digit. And slash capital D matches with a single non-digit. All right. And slash W matches with a single alphanumeric character. Here slash D only matches with a single digit, whereas slash D matches with the alphanumeric, both alpha and numeric characters, the single alphanumeric character. And also slash capital W matches with a single non-alphanumeric character. All right. And slash S, small s, matches with a single white space character. A white space could be a tab, a space, or a new line, etc. So yes, slash small s matches with a single white space character. And capital S, slash capital S matches with any single non-white space character. All right. And there's another one, slash B. Slash B is used for matching word boundaries. Okay, slash B matches with a word boundary. Let us see some code examples that will make it all this very clear. Let us copy a text here. I will use this text for testing these escape codes. Let us run a find all on this. Dot find all, right? We'll write a regular expression and followed with a text. All right? The regular expression, let us look for this numbers, numerical numbers. I'll say for that we can use a escape code, that is a slash D. Slash D will give a single numerical, it will look for a single numerical number. It will look for a numerical number. Let us see what we get. Slash D. If I execute this one, I get 125. Each, it is taking each as separately. We get a 1, 2, and we got 3 matches basically. We got 3 matches. Match on 1, 2, and 5. Suppose we want exactly the whole 125, not as 125. We can add a repeater. We can add a repeater. We can say, we can use a star or a plus. Let us use a plus. We get, if I execute this one, I get exactly 120. It picks 128 matches on 125. And let us see what happens, suppose if we use capital D, right? Instead of small d stands for a single digit. Suppose the capital D stands for a non-digit. If I execute this one, it is picking on all the non-digits. It is picking on T, H, E and all that, matching on all that. So, and also here also, suppose if you add a plus here, it will pick on the words. I mean, this whole thing, see, it has 2 matches. This is one match and this is the other match, right? If you see the text, these are all non-digits, right? It's matching on everything. It is trying to match because this is a greedy pattern. So it is matching on all the things up to here. So that is one match up to here. And it cannot match on this because 1, 2, 5 are digits, because this slash D looks for all non-digits. So finally then it is picking on dot. This is a non-digit. So that's why we got 2 matches with the cost of Python course is $, is as 1 match, and dot as a second match. Let us see a space character. Okay, suppose let us see, instead of D, I'll use a space character. All right, and let us see what we get. It has to match on all the spaces. Say the 1, 2, 3, 4, 5, 6. We must get 6 matches. 3 plus 3, 6 matches. All right, and suppose what is the capital S for this? Capital S is the opposite of a space, non-space character. If I execute this one, it will match on all the characters. And if you want to just make it as words, plus. It will plus means it will match multiple non-spaces. It will right, as much as possible. Suppose if you see the text here, so it will try to match, and it stops here because there is a space character. It's not a non-space, so it stops there. So this is what it finds. Then it moves on. Then it looks for. Then it gets cost. So that is about space and non-space. Then let us look for let us see an example with alphanumeric. I'll say let's look for W. W is for alphanumeric. Let us say let us use the plus, and if I execute this one, this is alphanumeric. So everything. It looks for alpha characters and numeric characters. This is all because we are using a plus. Suppose if we take out the plus, you'll get a bunch of all the characters. So instead of that, if you use a plus, it will pick. It will see till it sees a space. Alphanumeric means it only from letters A to Z, capitals and small letters, and plus the numerics 0 to 9. It will look only for those characters. If there is a right, suppose if you say, see, let us the text. When it sees a space, it stops there. It cannot pick that space. So that's why we got a word. That is my first match. The second match starts at here, and once it sees a non-numeric, non-alphanumeric, it stops there. So that's why we got these matches. And also, if you use capital W, it will be, if you use a capital W, then it will be non-alphanumeric. Let us see what we get. So it is getting all the matches with the non-alphanumeric, that is a space characters, and a dollar sign is also non-alphanumeric, and a dot is also non-alphanumeric dot character. All right. All about using escape codes in writing regular expressions. Then let us see anchoring. Okay, by using some special characters like a caret sign or a dollar sign, we can specify the regular expression engine where to look for the pattern in the given string. We can specify whether to look for the pattern in the beginning of the string or at the end of the string, or look for the word boundaries. All that we can specify by using anchoring, by using this anchor characters. That is a caret sign. Caret sign looks for the start of the string. Suppose if we give a pattern and if we specify to look in the beginning of the string, we can use a caret sign. And if we say if we want to look at the end of the string, end of the test string, you can give a dollar sign. If you put, also you can look for word boundaries by using a /p. Okay, and also the one more thing, we can use a caret sign for the start of the string, or also we can use /A. We can use for the start of the string, but normally people use the caret sign. The other thing is for the dollar sign, we use a dollar sign for the end of the string, and you can also use capital Z slash capital Z for end of the string. All right. Let us see some code examples. Let me copy a text for this testing the anchoring. Let us use our old text. This is a beautiful day. Let us look for again. Let us look for is word. Ra.findall. I specify as is. I want to look for is, and let us pass the text. If I execute this one, I get two is. This is and this is, right? And suppose if I want to look for this, look for the beginning in the beginning of the text, I have to put a caret sign in the beginning. That's how it is. You have to use. This is the anchoring. So you are saying that look for this pattern. This is, the word is, the string is in the beginning of the given text. If I do that, I get an empty list object, because there's nothing like is in the beginning of the string. All right. Suppose if I look for let us look for t. So there is a t in the beginning, then we get a t there. So that is in the beginning of the string. All right. And let us see a dollar. Let us see at the end of the string, right? And I can say I want to see whether there is a dot at end of the string. So that is how you have to specify. If you want to look at the end of the string, end the pattern with a dollar sign. And because dot has some meaning, stands for any character, it's better to nullify that effect with a backslash. If I execute this one, I get a dot, because there is a dot at the end of this. Suppose if I say look for k at the end of the string, I'll get an empty list object. All right. Next, let us see the word boundary. The text is this is a beautiful day, and let me go back to look for is, right? That is. But suppose you want to only look for this is, but not this. This is a part of the word this. So you don't want like that. You want just this is. You can use the word boundary anchoring on that. I'll say for that we have to say /b and /b around that word. Put a /b around this word, is word. If you say that, if you execute this one, you'll get this is. And but the thing is, we don't know which is we got, this is or this is. For that we can do what we can do is let us copy this, right, and change it with search. Search will give the exact locations where if I execute this one, this is what we got. The span is 5,7, means this is 5,7. All right. This is starts at 5 and ends at 7. So that is about anchoring, and let us move on to the next topic, the flags. Okay. Sometimes we need to slightly tweak the behavior of the regular expressions. Sometimes if you want to ignore a case, then we can use a ignore flag, re.ignore case, or we can say re.I, or we can just use a number. All right, to make the regular expression case insensitive. Okay, it will ignore the case when matching. Again, there is another flag called re.all. You know that a dot character is a representation of any character other than new line character, right? But if you use .all, re.all flag, it will include the new line character also. That is the purpose of this flag dot all. Next, multi-line, or you can use a re.m, or you can use a number 8. Suppose if your text is you're having a multi-lines, and this flag will make the caret sign and the dollar sign for the beginning to specify the beginning or the end of the line, which normally would apply to the whole text. So instead of that, this multi-line will make to look for each line instead of the whole text. So that is the purpose of this multi-line. And then there is a verbose. Verbose, you can use re.verbose or re.x or 64. You can use the number 64. What it does is makes a complicated regular expression to be more readable. Means you can add some comments within the pattern. Suppose if you are writing a very complicated pattern, and to make it more readable, we can add some comments in that by using a pound sign and all that. But for that, you have to use this flag re.verbose. Then there is a debug flag. The debug flag will provide, suppose if you are compiling when you are compiling the regular expression, and if you specify the re.debug, then it will provide some debugging information while compiling a regular expression. Finally, if you want to use multiple flags when calling the regular expressions methods, you can use a bitwise operator. This pipeline. We can say here, for example, here we're specifying re.I for ignoring the case, re.s for dot all, and re.m for multi-line. You can specify multiple flags by using bitwise operator. Let us see some code examples with flags. Let us use this text Python for testing some of the flags. Let us call re.findall. Let us look for Python. I'll say Python, and let us pass the text. Then we get one Python, right? This is what we got. So it is exactly matching on the case. Suppose if we want to match on all the three, we can specify the flag. We can just say in the last re.ignore. If we say re.ignore, it will match on all the three Pythons, right? Also this re.ignore, also we can say instead of that, we can say re.I, that, right? If we execute this one, you get the same thing. Or you can also pass a number. The number is 2. Number is if you say 2, but I don't advise to use this number, but the thing is, this is more readable. I mean, when you write code like this is more readable, or this is also okay, but not this number. How to find the number? So you can find the number by saying re.I or ignore case. It will give a number, right? The Python interpreter will tell you what exactly is that number. Similarly, if you say re.s for a dot all, it will give a number, right? And then let us see an example with re.all. Let us take this text. It's a Python with a /n in between, right? And if I say re.findall, right? And let us write the regular expression here, and let us pass the text. Right? Let us look for any character, right? I'll say look for this character dot, and let us put a repeater. We just want the whole word there, whole word. We want the whole word. If we execute this one, we get two words. One is pie and thon, because this dot will match only on it will match on any character other than slash in the new line character. So it is stopping there and it is continuing with this word. It's not matching on this. So for that we can use this flag, the dot all flag. I can say RE dot dot all. Right? If you execute this, you will get the whole word Python with a slash n. All right, that is the purpose of that dot all. For this, we can also use yes, or we can use a number. I think the number is 64, or you can find number is 16. Here it is. Better to use. I prefer this one. This is makes your code more readable. All right. Next, let us see one more example. Use this string now as a text equal to Python is fun and learning Python. Let us let us try with a sub. Sub is for substitution, sub method. And look, I'll say my pattern is pie, right? And I want to replace with let us say mine, right? And I'll pass the text. So that is my sub method. Sub is for substitution, and I'm looking for py, and I want to replace with the mine, right? Let us see what we get. So Python is fun, learning Python, right? Here what happened is this is not replaced, because this is looking for capital P and Y, whereas here it is small p. So you know what we can use? Ignore case flag. Here suppose we can say after text, if we say re.I, that will ignore the case. Now if we execute this, Python is fun, learning Python. Why we got the same thing? Here we have to say flags. For this, for sub we have to use say flags. If we execute this one, we get Python. Let's say Python is replaced. And suppose if you want to, also we can say in sub we can specify the number of replacements, right? Suppose if I say count equal to 1, right? Then there will be only one change here, Python. So that is all about flags. And in this class we learned 3 things. One is how to use escape codes, and the second is how to use anchoring characters, that and how to use flags. So we covered these 3 topics in this class. In the next class we'll cover groups and named groups. Okay, thanks. Hi, welcome back. In this class we'll look into grouping and named groups in regular expressions. Regular expressions provide a mechanism to split the expression into groups. When we are using groups, we'll be able to select each individual group within the match in addition to the entire match. We can specify groups within a regular expression by using parentheses. Let us see a code example that will be more clear for you. Let us use this text 1, 2, 3, 4, 5, 6, 7 is my telephone. Let us write a regular expression to match on these characters, to pull these characters out. I'll say, let us start with the re.findall. and we'll write the regular expression here and pass the text. All right. And how to write this regular expression to get this number. So for numbers, we can use a escape code /d. All right. And also we will use a character sets. All right. I'll say within the character set, I will say /d. /d represents a character, a digit, in a single digit. So we want here there are 3 digits. So we can specify a repetition. How do you specify a repetition? By using the curly brackets. We can specify exactly that we are looking for 3 digits. All right. After that, let us look for a dash. So we are looking for a dash after that, right? Again, let us look for 4 characters. I'll say /d again and use curly brackets and 4. First, we are looking for 3 digits. After that, 4 digits. In between, there is a dash. And this is just a regular expression, no grouping. Just let us see what we get. So that is perfect. So we got the number, the telephone number 1234567. That is a local telephone number. Suppose if we want to group, suppose we want to make this as one group, this output, this as one group, and this is another group. How do we do that? We can use parentheses. We can let us copy this. For grouping, we have to use parentheses. This is one. This is I'll start a parenthesis here and end here. That is my group 1. The second group I start from here, and this is my second group. So I have 2 groups in this regular expression, and if I execute, let us see what we get. And also when you group, we can create a match. It will return a. Let us do, instead of find all, let us do a search, and search will return a match object, right? If I execute this one, I get a match object, right? And if you want to print m, that is fine. You can there's a match object, the match is found, and we can say, this method. If we say group, it will give the entire match. That is 1 2 3 4 5 6 7. That is the entire group. And if we say m dot groups will give the individual groups. 1 2 3 was we grouped here. One as the first 3 characters we grouped, and second 4 characters we grouped. So that we got 2 groups. And also if you want to see the individual ones, we can say m dot group 1. Group 1 will give 1 2 3. And if we say m dot group 2, that is the second group, it will give group 2. So that is all about grouping. So in our search pattern, we grouped the regular expression as 2 groups. And also we can give some name to this, and we can give, instead of calling as group 1 and group 2. Suppose when you're writing a complicated regular expression, this will be useful, the grouping and all that. And also we can give some names. Instead of using 1 2 and these numbers, we can give a name also. The name is given by this code. Let's start with the question mark and a capital P and the group name. This is the group name. This is what you have to say. This is what you have to include within the group. Let us try this one. I'll take the same one, right? And here after starting the parenthesis for the group, you have to specify, you can give a name. How do you give the name? Start with a question mark and a capital P, and with two angular brackets. Within the angular brackets, you give a name. I'll just give a name, let us say, I'll say first. I'll say, what is it? First three, the first three numbers, right? Similarly, let us copy this, and we can put, in the second group, I'll say last four. So that is, I'm giving a names to the groups. And if I execute this, and if I say m dot group, I can specify with the name. I'll say first three, we'll give 1 to 3. All right, that is the use of having a named groups. The second one, I can say last 4. That is 4, 5, 6, 7. All right. So that's all about grouping and named groups. Let us recap. We saw all these different ways of writing regular expressions by using repetition characters, and also by how to use non-greedy repetition characters and character sets and character ranges, escape codes, anchoring, flags, groups, and named groups. All these we have seen with code examples, and we'll stop here, and in the next class we'll write a couple of complicated regular expressions by using all these features. Okay, thanks. Hi, welcome back. In this class, we'll write a regular expression, a little complicated regular expression, by using all the features we learned in writing a regular expression. Let's take a text as say text equal to a list object with a telephone, with a couple of telephone numbers. I'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 0. That is one type of a telephone number. And also the telephone number could be like within the codes 1, 2, 3. That is a area code. Then 4, 5, 6, 7, 8, 9, 0. So we have two types of telephone numbers. The first one, the area code is enclosed within parenthesis. And let us write a pattern for this. I'll say pat, right? And we'll use a raw string or, and let us see this one. Starts with a digit. There are 3 digits in the between, in the start. So I'll say /d. /d starts for escape code for digit, /d, and we have 3 digits. So we will use a repetitor. We'll say, I'll say 3 digits. By using the curly brackets, we can specify how many preceding characters we are looking for. Here it looks for 3 characters, and followed with a space. /s is a space, right? And then again 3 digits. I'll say /d, curly bracket 3, and then again a space, right? And followed with 4 digits. I say /d and a curly bracket with 4, right? Let us see what we get with this. I'll write because this is a list object, I'll write a for loop here. All right, for d in text, or I'll say dt in text, right? I loop through using a for loop with each item in this list object. I'll say m equal to re. I will do a search. I will call a search method in a regular expressions. I will do a search. For search, I will pass the pattern. That is the pattern we wrote. This is the pattern, and I'll pass dt. dt is a date. I mean, this is a string, is item, one of the items in the list object. And if a match is found, if I can say if m, then I say print m dot group. M dot group will give the entire match. There are no groups here, but m dot group will give the entire match. Suppose if I execute this one, we got some error. re is we have to import re first. I have to say import re. All right. Suppose if I execute this one, we got is able to pull this number 1 2 3 4 5 6 7 8 9 0, right? And but it's not doing this one because it's starting with a parenthesis. So let us modify our search pattern now. I'll copy these two. I'll include the parenthesis here. So the parenthesis, or I'll say slash parenthesis, right? And here also again slash the closing parenthesis, right? And let me copy this one. Let me copy the code also here within this. See, let us see what I get now. If I execute this one now, I got the second telephone number, not the first one. For that, we have to say we can put a repeater here. We can change the pattern here. Let us copy to a third one. I'll change the parenthesis. I'll put a question mark there. Means 0 or 1 occurrences of that parenthesis. Similarly, here I can put a question mark. So that will say that either 0 times or 1 time of that the preceding character. If I execute, we must get that both the telephone numbers, right? So it's picking up both the telephone numbers from this list object. All right, and let us add a couple of one more telephone number. I'll say let's copy this one, right? And for this, let us add one different type of telephone number. I will say 123 dash 456 dash 7890. With instead of having spaces, it has dashes. So for this, what we can do is we have to change this one. So here we are specifying a space here. Here one space and this space and this space. So for that, we'll put here instead of space, we'll put a character set. I'll say within the brackets, within the square brackets, as I look for a space or a dash, right? Or a dash or a space. Similarly here, I'll replace this space character with a character set slash s or slash dash. All right, let us see what we get right now. If I execute this one, I got some problem. Okay. So I didn't close this square bracket. That was a problem. Okay. If I execute this one, we are able to pick up the 3 telephone numbers. 1, 2, 3 is for the first one with the spaces, the second one with the enclosing with the parenthesis, the area code, the third one with the dashes. All right, and let us add one more telephone number. I'll say copy this, and I'll say one more telephone number. It will be 123.456.7890. So instead of dashes, we'll have a dot. So that this change will be very simple. I'll just add dot also here, slash dot. So we'll see, it will look for one of these characters, either a space or a dash or a dot. So this also will be dot. All right. If I execute this one, we must be able to see all the 4 telephone numbers. All right. Let us change this one. Let us add one more telephone number. Say no spaces, nothing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. This is also a valid telephone number. So if I use this one, if I execute this right now, it won't pick up this number, right? For that, what we can do is here the space, we can make it an optional. For that we can put that repeater, the question mark, means is a 0 or 1 time of the preceding character. The preceding character is one of these, right? Same thing here, we can put a question mark here, and that will make this character as a optional, as a 0 times or 1 time. Let us see what we get right now. So it's picking up the last telephone number also. So this is the pattern. So, it's a quite complicated pattern, but the thing is, you must always start with the a simple one. For example, start with the simple one and then build on that. That will be the way to write these regular expressions. It is very tough to write a regular expression right away with like this, but start with a simple one and then continue with that. Then let us add some more to this. Let us add one. Let us take this one. See, some telephone numbers may have the one in front of it, right? Or a +1 in front of it, right? For that, we have to make changes. Let us may change the pattern, and in the beginning, let us look for a digit, right? I'll say /digit, but that /digit is optional. All right, I'll say /digit, right? And after that, there's a space character, right? That's how. Let us see what it picks up. It is picking up this one and this one, and it is ignoring all the rest, right? Let us put a question mark here. Let us see what we get. To make this space character optional, and if we execute this one, then we are picking all the telephone numbers. So it's not only picking the one before, and also the rest of it. And also let us pick this plus also. Okay, how to pick that plus? The plus is in front of it, starting, right? I'll say the /plus, and I will make it as an optional, right? If I execute this one, we're getting the plus also. So the full telephone number with the plus 1, 2, 3 and all. So that is how to write complicated patterns. But let us compile this. This is where the compilation will help. I'll say I'll take this one. I'll copy this. Let us compile this one. I'll say PAT-C. PAT-C is a compiled version of PAT. I'll say re.compile re.compile, I'll pass batch, right? And here I'll use a compiled version. Let us see what we get. That's more better. If I execute, I'll get the same thing. Now it's using a compiled version of the pattern. All right. I think this is a very good example in showing how to write regular expression patterns and using all these escape characters and repeaters and all this. Actually, we can make it more interesting by grouping. Let us group this. Copy this one. All right. Let us add a groups to this. First, starting with that plus number, I'll start a group here with a parenthesis, and group ends here. This is the first group, and the second group starts here before here. Actually here. This is my second group, and the second group ends here. All right, and the third group starts here and ends here. All right, and the fourth group will start here and ends here. That is we are creating 4 groups. First with that plus number, for this plus number. The second one is with the area code 1, 2, 3, third one and fourth one. All right, and let us slightly change this output because right now we are doing with the groups. We'll say first one we can say m dot group, and then we will say m dot group 1. Let us print group 1, and let us copy this. I'll say second one, comma, third one, and fourth one. I'll change to 2, this second group, third group, and the fourth. Let us see what we get by executing this one. If I execute this one, yeah, we got some output, but it's all jumped up. Let's add some tabs. I'll add a tab T. Let me add these tabs to Control C, group 1, and here I will add, and again here and here. Let us some tabs just to make it a little more readable. If I execute this one, say this is a little better. Still we can improve, but this is okay. So this is the whole thing. This is a whole match, and this is the group 1, group 2, group 3, group 4. Similarly here the plus 1 is group 1, group 2, group 3, and group 4. Okay. Finally, let us give a names to these groups. Naming groups. I'll copy this one. All right. The first group, the naming, we have to give a name after the parenthesis, immediately after the parenthesis. I'll say how to do that. Is starts with a question mark and capital P and angular brackets. Within the angular brackets, we can give a name. I'll say add 1. That is my first group. Let me copy this, and the second group starts here, right? And I'll say area code, and the third group, this is the second group, this is the third group. I'll say add, and also I'll add here, add, and this is let's call the name first 3, first 3, and this is the last 4, right? And if I execute, we will get the same this one, but here we can change it. Instead of group 1, we can say we can say we can pass that label add one, right? Here we can say area, and here we can say first 3, and let us move it on to the next one. Say last 4. If we execute, we'll be getting the same output. We got the same output, but the only thing is we gave a labels to these groups. First one is add one, area, first 3, first last 4. So whenever you are accessing the match, we can access with these labels. All right. So that is all about writing a complex regular expression. It's always advisable to start with a small expression, and keep on building with that. Okay. We'll stop here, and we'll meet in the next class. Okay. Thanks.